In this lesson, we are going to learn on derivative of trigonometric functions. The learning outcomes of today's lesson is to differentiate the trigonometric functions. These are the derivative of 6 basic trigonometric functions, or known as trigonometric rules. If we differentiate sine x, we will get cos x. Differentiate cos x, we will get negative sine x. Differentiate tangent x, we will get secant square x. Differentiate secant x, we will get secant x tangent x. Differentiate cosecant x, we will get it as negative cosecant x cotangent x, and differentiate cotangent x is equal to negative cosecant square x. Let's say we have y is equal to sine 2x. How are we going to find the dy dx? The previous slide on the trigonometric rules only give differentiation for single x, such as y is equal to sine x, y is equal to cos x, or y is equal to tangent x, and others. But how if we have y is equal to cos x squared plus 3, or if we have y is equal to tangent cos x? How are we going to find the dy dx? The next slide will discuss on that. In this slide, we have tables 1 and 2. Table 1 is on the basic trigonometric rules that has been discussed in the previous slide. Table 2 is the extended trigonometric rules that will solve the differentiation of functions such as sine 2x, cos x squared, and others. Table 2 is actually based on table 1. Now, we look at table 1. If we differentiate sine x, we will get cos x. Now, we move to table 2. If we differentiate sine fx, where fx can be any function, we will get cos fx times with f prime x. We notice here that the differentiation concept is similar with sine x in table 1, but here in table 2, we will replace the x with fx and multiply with f prime x. Similarly, if we look at the second row of table 1, if we differentiate cos x, we will get negative sine x. And if we move to second row of table 2, we differentiate cos fx, we will get negative sine fx and multiply with f prime x. The differentiation follows exactly the basic trigonometric rules for differentiation of cos x. If we look at here, differentiation for cos x, we have negative sign here. Now, if we differentiate cos fx, we will also have to add up the negative sign, x replaced with fx, and multiply with f prime x. In general, the differentiation for sine x, cos fx, and others will follow the rules of basic trigonometric rules, and x replaced with fx, and also multiply with f prime x. Okay, let's say we have y is equal to sine 3x. So if you look at this one, y is equal to sine 3x, it is in the family of y is equal to sine fx. And as we have discussed in the previous slide, dy dx for this sine fx is cos fx multiply with f prime x. So here in this case, okay, we need to determine the fx. Fx in this case is, okay, comes from here, okay, sine something. So in this case, fx is equal to 3x. So the f prime x we get is equal to 3. And then now we want to find dy dx. Okay, based on this formula, okay, we bring this formula. So we get here cos fx. So therefore we get cos fx is 3x. Multiply with f prime x is equal to 3. So therefore we get 3 cos 3x. Okay, next example. Okay, we have y is equal to cos x powers of 3 plus 2. Okay, so if you look at here, the y cos x power of 3 plus 2, it is in the family of y is equal to cos fx. Okay, when we differentiate it, we will get it as dy per dx as negative sine fx multiply with f prime x. So this is the family of cos fx. Alright, so here, okay, the fx here, okay, it is equal to x cubic plus 2, so it comes from here, so this would be the fx, and the f prime x, if we differentiate that, we get is equal to 3x squared. So therefore, if you want to find dy dx, okay, the dy dx, we are going to use this formula. It comes taken from here, so we have here negative sine x cubic plus 2, okay, multiply with f prime x, 3x squared. So therefore, if we write it back, we can write it as negative 3x squared sine x cubic plus 2. Okay, so that is the dy dx. Example, we want to find the dy dx for y is equal to tangent cos x. So y is equal to tangent cos x, it falls in the family of y is equal to tangent fx. So where the dy dx, okay, as we have discussed before, is equal to secant squared fx multiply with f prime x. So here the fx in this case, okay, it is equal to cos x. Okay, this is the fx, your fx, okay, cos x, and differentiate cos x, we get negative sine x. So now therefore the dy dx would be is equal to, okay, we take the formula, this formula, it comes from here, so we have dy dx is equal to secant squared cos x and multiply with negative sine x. So at last we get it as negative sine x secant squared cos x. So this is the dy dx. Okay, let's say we have y is equal to x squared cos 2x. So if you look at here, okay, y is a multiplication between x squared and cos 2x. So therefore, we need to use the UV product rule. So in this case, the u is equal to x squared. So it comes from here. This is the u. And the v here is cos 2x. Okay, this is the v. Okay, now we need to find the u prime. Differentiate, we get 2x here. Okay, so the v, if you look at here, v, it is in the family of cos fx. If we remember, if we differentiate cos fx, we will get it as v prime is negative sine fx multiply with f prime x. So therefore, if we're referring to this one, okay, so we get the v prime is equal to negative sine 2x multiply with f prime x, we get 2, so we get v prime is negative 2 sine 2x. So since the y, it is in terms of the product between two functions, so dy dx, we need to use the formula for product rule, u v prime plus v u prime. So every time, okay, vu prime. So every time we need to write this formula, and after that we are going to substitute the value for u, v, u prime and v prime. So we get here x squared multiply with v prime negative 2 sine 2x, okay, plus with v is the cos 2x, okay, multiply with 2x. Alright, multiply with 2x. So when we expand it, we get negative 2x squared sine 2x plus 2x cos 2x. Okay, so please bear in mind, we cannot multiply this x to x. Okay, it is two different things. Okay, so we need to write it as 2x cos 2x. So after that, okay, if we still can simplify it. So by taking out the factor for negative 2x, so if we take out the negative 2x factors, we get here a negative 2x, so it becomes x squared x sine 2x minus cos 2x. So this is the dy dx for this question. Okay, let's say we have y is equal to cos x divided by 2 plus sine 3x. So if you can see that the y, it is in terms of quotient form. Okay, with the u is equal to cos x, come from the numerator part. This is the u here. Okay, and the v is equal to 2 plus sine 3x, comes from the denominator part. Okay, now we want to find the u prime. U prime, if we differentiate, we get negative sine x. And the v prime, okay, if we differentiate that, we get 0 plus 3 cos 3x, or we can write it as 3 cos 3x. So since the y, it is in terms of quotient form, so we are going to write the formula for dy dx using quotient rule. So we have vu prime minus uv prime divided by v squared. We substitute the value for uv, u prime, and so on. So we get 2 plus sine 3x multiply with u prime is 3 cos, u prime. Okay, u prime is negative sine x minus with u is cos x and v prime is 3 cos 3x. Okay, divide with 2 plus sine 3x squared. Okay, so if we expand the numerator, we get it as negative 2 sine x minus sine x sine 3x minus 3 cos x cos 3x divided by 2 plus sine 3x squared. So that is the dy dx. Okay, finally, you can try the question given here. We will discuss the question in the next lesson. Okay, that's all for today.